So before we look at the stopping potentials, we're going to need to do a tiny bit of work on electrical stuff. Now this is something we're going to talk about much more in its own unit later, but we just need to be familiar with the bare bones of this now so we can make sense of how stopping potentials actually work. So it takes work, that is to say we need to expend energy to move a charge through a potential difference. So what does a potential difference mean? Well, all it means is that our electron has more potential energy, say here, than it does here. And we use V for potential difference. So this V, this just means that's the symbol we use to represent potential difference. And we're saying, and a good interpretation of what this can mean is that we basically have two charged plates. So two charged plates here. This one is negatively charged. That's what this minus sign represents. And this one is positively charged. What that means is this electron is going to be attracted to this plate and repelled by this one. So it's got a net force, this F, in this direction. But we're moving it with this dark green arrow in this direction. So what we say is that our electron here has a higher potential than it does here. So when our electron reaches this point, it's going to have a higher potential than if it was at this point. That's why there's a potential difference between the two plates, and it takes energy to move something from a lower potential to a higher potential. That's because this thing experiences a force, this electron experiences a force in this direction. It wants to be closer to this positive plate, and so we have to put energy in to move it in the direction it doesn't want to go, which is towards this negatively charged plate. That puts it at a higher potential. Now, a really good way of understanding this is just thinking about lifting a mass under gravity. Now, this is something we're going to look a lot at later, and we'll come up with formulas and stuff for it, but we don't really need to worry about that now. All we're saying is that we can actually see this as basically being the same thing. Instead of this being a potential difference, we're not going to call it that, though there is a potential difference involved. What we're going to say is that moving an electron over this potential, basically through this potential difference, is the same as moving this mass, say this ball, up by a height of, say, h under gravity. So this is the Earth's surface. This is just some height of h. This is the weight of our particle, and we're moving it in this direction. And so what we see is that it's experiencing this net force down towards the Earth. So if we want to move it up here, we have to put in energy. And so what we're actually saying is we're moving it to a higher potential. So this place at height h has a higher potential than here on the Earth's surface, where it's a lower potential. Now the key thing to note is that it's actually not the absolute value of the potential that matters. All that matters is that there's a difference between the two. You know, this could still be really, really high potential. It's not because we're on the Earth's surface. But what we're saying is that all we're saying is that there's a net difference between the two. It doesn't matter actually about the specific value of this one or the specific value of this one. All it matters is that V, this difference.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.